Greetings. Welcome to W2U2, Merrill's First Principles of Instruction, Part 2. In the earlier unit, we presented Merrill's five first principles of instruction, Part 1. We discussed the motivation for Merrill's first principles, and then we discussed the task centered principle, the other principles that follow the task centered principle. The outcomes of this unit would be to understand the remaining part of Merrill's principles and the other issues related to the use of Merrill's principles. So, the outcome is understand Merrill's five first principles of instruction, part 2. So, we noted that Merrill's five first principles of instruction are task centered principle, activation principle, demonstration principle, application principle, and integration principles. We discussed the first three principles in the previous unit. In this unit, we will present the remaining two principles and then conclude the discussion of Merrill's FPI, first principles of instruction. So, the next principle is application principle. Let me. Learning is promoted when learners are required to use their new knowledge or skill to solve the problems. In the demonstration phase, the instructor has demonstrated the solution of the task. Now, the learners apply what they have learned to solve the problem. And the time lag between the demonstration and application by the learners should ideally be extremely small. In the same instructional unit, learners must continue with the application after demonstration. And this might require careful planning of the instructional unit, but it is required. So, learning is promoted when learners are required to use their new knowledge or skill to solve problems. Merrill observes that while there is a near universal agreement on the importance of applying knowledge to real world tasks, much instruction merely includes a few multiple choice questions that are labeled practice. Students really do not engage with a real world whole task and they do not really apply their newly acquired knowledge or skill to solve a real world problem. So, the learning suffers because of that. The next important point is practice consistency. Learning is promoted when the application, that is practice, is consistent with the intended learning outcome. What is the competency that the student is supposed to acquire and demonstrate? That must be consistent with the practice that the student actually engages in. Then, diminishing coaching, learning is promoted when learners are coached effectively and when this coaching is gradually withdrawn. Initially, the coaching can be quite extensive to help the learner, but gradually the coaching must be withdrawn and a student must be able to work more or less independently. Then, learning is promoted when learners are required to solve a sequence of varied problems. What does practice consistency mean? Learning is promoted when the practice is consistent with the learning outcome. So, as we just now discussed, the course outcome or the competency which states what the learner is supposed to be able to do is actually what the learners is practicing to do. Thus, the practice is consistent with the competency expected of the learner. Diminishing coaching means that learning is promoted when learners are guided in their problem solving by appropriate feedback and coaching, including error detection and correction. Coaching is quite helpful early in the learning as students may need considerable support. As the learning progresses, this support is gradually withdrawn. This idea has been called scaffolding in several other instructional models and several other empirical study areas. What we are trying to say is that in the early stages of learning, considerable assistance is provided to the learner in solving the problem. The instructor may help with error detection and help with the correcting those errors, and importantly, the instructor provides appropriate and immediate feedback to the learners and so on. So the coaching is extensive, but the aim is that gradually the coaching is reduced and the learner starts applying the principles on his own or her own. So gradually the learner starts operating more or less independently. That is the idea of scaffolding. Feedback plays a very significant role in promoting good learning. It is recognized universally. And of course, the feedback must be an encouraging one and a positive one instead of becoming negative and demotivating for the learners. This all good teachers are aware of. Coaching must help the learners to understand how to recognize their errors. It is just not sufficient for the instructor to point out the error, but the instructor must help the learners to understand how to recognize their own errors and how to recover from those errors and how to avoid such errors in the future. So, help in all these aspects is required. The instructor must provide such a help. Recognizing the errors, recovering from the errors, and avoiding such errors in the future. Here again, diminishing coaching will promote good learning. Adequate practice must provide multiple opportunities for learners to use their knowledge or skills for a variety of problems to promote good learning. That is, varied problems are presented to the learners. This will promote good learning. Looking at some examples, again consider the task of sorting a given array of data elements using merge sort and quick sort. Learners are now given a specific array to be sorted, say 47, 19, 22, 27, 16. Learners sort the array initially using merge sort. Results of all the intermediate steps are also recorded, that is, splitting the array, sorting them, merging the sorted subarrays. All these steps, intermediate steps, are recorded and the results are shown explicitly. Tutor provides help by checking the working throughout, step by step, and pointing out the errors, if any, giving appropriate feedback. Learners continue the practice in the laboratory using an appropriate development environment depending upon what is available and what the instructor chooses. Maybe something like Eclipse or Visual C++ or any other quick C, whatever is available and whatever is the part of the instructions lesson plan. Then learners repeat the practice with the same specific problem using the other algorithm, quicksort algorithm. Learners trace each recursive call and observe the lists generated after each such call in the working of the quick start algorithm. The tutor helps the learners see the working of the recursion. Using appropriate debugging tools in the development environment, the learners continue the practice in the laboratory. Then let us look at an example of progressive withdrawal of coaching or scaffolding. The main task is solve for voltage and currents in a given series parallel circuit using Kirchhoff's voltage law and Kirchhoff's current law, KVL and KCL, from a basic course in analysis of electrical circuits. The first stage where the coaching is full, that is, the guidance is full, can be like this, that is, fully guided coaching. The task is solve for currents and voltages in a given resistive circuit. So we have just a circuit with only resistance. Instructor provides step-by-step walkthrough with explicit hints like start labeling all node voltages, apply KCL at node A, etc. That means it is a very detailed coaching with specific instructions to the learner, and it is a step-by-step process. So it is a fully guided coaching. Learner solve the problem closely following the instructor. That is, here basically the learner is following the instructor's guidelines and solving the problem. The next stage would be to withdraw the coaching partially. So the task can be solve a new but similar circuit, a circuit similar to the one solved earlier when the coaching was fully guided coaching. Instructor now provides only strategic support and prompts like have you considered all loops for the KVL? That is, the support is there, but it is partial. An important point, if it is missed, may be indicated by the instructor. So, instructor or the tutor closely follows the student's work and intervenes only when necessary. Learner performs steps more independently compared to the previous level. Like this, depending upon the lesson plan, there could be a series of tasks with increasing complexity and gradually increasing withdrawal of the coaching, so that the students are encouraged to work on their own. Students have to apply the principles, concepts, knowledge, skills learnt on the new problems on their own. So it can culminate in the complete withdrawal of coaching. The task can be solve a real world problem such as a complete power supply circuit. The instructor support, none. It is a complete withdrawal of coaching. Learner works solo or in a team. Instructor may only assess the final report or circuit. Learner is able to apply all learned principles in context and justify the approach and results. So, that would be an example of progressive withdrawal of coaching, uh, and you can see this in the form of figure that we have fully guided coaching where the instructor support is very high. At the next level, we have partial coaching where the instructor support is medium, and the next level can be minimal coaching where the instructor support is very low. Then finally, it is no coaching, that is, the instructor support is nil and learners work independently. Of course, here it's only 4 stages that are shown, but the actual number of stages would depend upon the instructor's design. The Next principle and the last principle is integration principle. Learning is promoted when learners integrate their newly acquired knowledge into their internal cognitive structures by being directed to reflect on it. Reflection helps learners in retaining what is learned. In almost all the instructional models, it is considered as an extremely important aspect of learning. Integration helps the learners acquire deep knowledge of the new skills acquired, new knowledge developed. It gets integrated with the prior cognitive structures. So, learning from integration is enhanced when learners publicly demonstrate their new knowledge by peer discussion and peer critique. That is, learners play the role of a teacher. When learners create, invent, or explore personal ways to use the new knowledge or skill. When learner can observe his or her own progress, learning becomes a strong motivation by itself. The learner is able to show to peers, to himself also, that he has learnt or acquired new skills. So, when learner can observe that, it becomes a huge motivation for learning. Effective instruction must provide an opportunity for learners to demonstrate their newly acquired skills. It can be a short presentation in the classroom, it can be writing a term paper and presenting it, or it can be a group presentation. There are a variety of methods depending upon the instructional method chosen. But the important point is that the learner demonstrates the learning or the new skills acquired by him or her. The principle of going public with their newly acquired knowledge is emphasized in several instructional models. Learning is promoted when a learner plays the role of a teacher, engages in peer discussion, receives peer critique, and is able to defend his or her newly acquired knowledge and skills. That is, effectively, the learner plays the role of a teacher for a while and then receives the critique from the peers and is able to defend his or her newly acquired knowledge and skills. So, this enhances learning. Learners need the opportunity to reflect on, defend, and share what they have learned if it is to become part of their internalized cognitive structures. This is the idea of reflection. It is essential that learners in, are given an opportunity to engage in reflection before proceeding with the imparting of further new knowledge or skills. At the end of the instruction phase, after the entire cycle, the learners must be given an opportunity to reflect on what they have learned, what new knowledge and skills they have acquired, and this will help them internalize this new knowledge and skills. So, learning is promoted when obviously learners create, invent, or explore personal ways to new knowledge or skill. This we have mentioned earlier already. Some examples. Again, sort a given array of data elements using merge sort and quick sort. Instructor may prompt the learner to reflect on the differences between merge sort and quick sort in terms of performance, in terms of the time and space requirements, that is, recursion, and memory use. Further, the learners may be encouraged to explore the context where one would prefer one algorithm over the other one. Learner may prepare a table comparing the two algorithms. He or she can try to explain how one should choose between these algorithms for a real world data set. Example, sorting marks list of students in a classroom, financial records of an individual, etc. Merrill's five principles do not form merely a collection of separate blueprints that might be used in designing effective instruction. We saw that there are five principles, but they are all interrelated. In fact, Merrill's idea was to have these principles as interrelated principles and prescriptive principles. These principles together form a four-phase cycle of effective instruction needed for teaching any whole task. This is shown in the next figure, that is four-phase cycle of learning. In this cycle, the first phase is activation. This is followed by demonstration. Then we have the application phase, and finally we have the integrate phase. You can see this. And all these phases are task centered. That is, we start with the course outcome or competency, and then we activate the prior knowledge structures. Then instructor demonstrates the solution of the problem. Then the learners apply what they have learned. Then they are allowed, or they are in fact prompted to reflect on what they have learned, and they enter into the final phase of integration. So these four phases have this kind of structure, guidance, coaching, reflection ideas. The activation phase allows the learners to structure the new knowledge by activating the prior cognitive structures, the knowledge structures which they already familiar with. That forms the basis. So this is the structuring step. Then during the demonstration phase, instructor provides the guidance, shows how the problem is solved. So the instructor is essentially playing the role of a guide or coach. And the application phase, where the instructor really coaches the learners. The demonstration phase is as an expert. The instructor provides the guidance. In the application phase, the learner is working with the problem and the instructor plays the role of a coach. And during the integration phase, the learners reflect on what they have learned. So, structure, guidance, coaching, reflection. These are the four aspects of the four phases of learning cycle. Generally, information only instruction with, remember what I told you, kind of questions tacked on to the end is considered as a low level of instructional strategy. That is a demonstration which does not have uh, uh, any portrayal, but it's only the presentation of the information is generally considered as low level instruction strategy. As more of the first principles of Merrill get implemented in the instruction strategy, the strategy will reach higher levels of quality. Almost all the instructional models reported in the literature include at least some of the first principles. However, the terminology and the implementation details do differ considerably among these models. But what is very important is that none of the models contradicts any of these principles. So there is no contradiction. Perhaps the terminology is different. Perhaps not all the principles are included. Perhaps some additional principles are present in an instructional model, but none of the models contradict any of these principles, Merrill's principles. Like the principles which are present in some other models but which are not present in Merrill are multiple intelligences or Howard Gardner, collaboration, Nelson and many other researchers. These are all present in other models, but somehow Merrill did not include them in the first principles of instruction for his own reasoning and understanding. So these principles are missing in the Merrill's principles. However, all the Merrill's principles are present, and these principles do not contradict Merrill's principles. So instructors can use them as required, as they do not conflict with FPI. The instructors can choose an instructional model which incorporates these principles. Later, in fact, we'll spend time on instruction models that use collaboration and project both mode of learning. All these issues we will discuss. So, Merrill distilled a set of interrelated prescriptive principles for instruction design after reviewing several instructional models. Principles are not in and of themselves a model or method of instruction. These principles can be implemented by different models and methods. We will see one or two models which implement Merrill's principles in the next units. So, the five first principles are task centered principle, activation principle, demonstration principle, application principle, integration principle. And we repeat, as more of these first principles get implemented in instructional strategy, the instructional strategy will reach higher levels. Once again, we gratefully acknowledge the help from colleagues who participated in our earlier workshops and Gen AI tools, including ChatGPT 4.0, in generating examples and associated figures. That completes our discussion of Merrill's first principles of instruction. In the next unit, that is W2U3, we will understand Kolb's theory of experiential learning. Thank you, and we will meet with the next unit. Thank you.